Hey everyone, welcome to the Unhandled Exception podcast. I'm Dan Clark and this is episode number 24. And today I'm joined by Steve Collins to chat all about dependency injection in .NET. Now Steve is an independent software architect and developer, a blogger and a public speaker. And he's done many talks now at various UK user groups and also the DDD conferences, which I think that's initially how we got to know each other.
Yeah, I think it was DDD Reading. I think we first met, yeah.
Yeah, I think we've met at quite a few of them now, and you've also done this year NDC London, which is quite big.
Yeah, that was very exciting. Just a shame it was virtual rather than in person this year, but hey-ho, it was still a feather in the cap.
Yeah, definitely. I don't know when it's going to go back physical again, but maybe next year.
Fingers crossed.
Yeah, things are starting to. I don't know what I'm going to do with .NET Oxford, but things are starting to go physical now. We'll see what happens. Well, so yeah, massive welcome to the show, and I think this podcast recording has been a long time coming, hasn't it?
Yes, I think it was back in February we spoke, and then schedules have just got in the way.
I know, yeah. Well, it was quite well timed because in February you did a similar related talk at .NET Oxford, the user group I run, talking all about this, so you gave me a bit of a source to prep for this.
Excellent.
Cool. So before we start, I'm going to do this episode's listener mention, and this one goes to Dave Williamson, who is DaveW039 on Twitter, and he tweeted, "Just listened to fellow JetBrains Rider fan at Drakan," so at Drakan's me, Drakan's great podcast where he talks to Martin Ballio and Kira Scragan about Rider, Code With Me and more. Definitely worth a listen. So he's referring to episode 22, so thank you for the tweet, Dave. So I suspect that most developers nowadays probably use dependency injection in some form or another. But then there's plenty of other related terms like dependency inversion, inversion of control containers, and so on. So is demystifying these terms a good place to start before we dig a bit deeper?
Yeah, sure. Maybe we'll start with inversion of control and dependency inversion principle, which pretty much the same thing. Steve Smith's got a good phrase that sums up how we used to do things, which is new is glue. You'll write some code, you'll new up an object, you've got it, and then if it's disposable, you'll destroy it within your own code. But the problem with that is because your code, that new instantiation is embedded inside your code, you've got no way of replacing it or substituting it when you want to test it. So when you look at things like the solid principles, which talk about dependency inversion principle, then with that, what you're doing is you're saying, instead of me newing it up, I'm expecting someone else to new it up for me, and I will consume what they've given me. So that's the dependency inversion principle, or inversion of control. Dependency injection is kind of the yin and yang to that, in that dependency injection is the thing that's going to give you the object. It will take care of newing it up for you, which doesn't sound like a big task, but if the thing that's being newed up has got various dependencies itself, it creates the object graph of A will go and create B, will go and create C, go and create D for you.
So that's the inversion of control container which does that for you?
Yeah. But it tends to just commonly be called the inversion of control container or the dependency injection container, dependency injection service. So many names, but they all pretty much boil down to the same thing.
Looking at our Google Docs notes, a lot of the stuff we're going to be chatting about is actually the .NET IOC inversion of control container. I know that quite a few years ago I used to default to third-party ones like Ninject or Autofac. I think Autofac became my favourite for quite a long time. But now, I get a thumbs up off Steve, the listeners can't see, but nowadays I tend to just default to the built-in one because it seems to give me everything I need. Everything I do is in .NET. Is that kind of what you'd recommend nowadays, or does Autofac give you more stuff?
Yeah, well, it's interesting you say that because, like you, before .NET Core and obviously .NET 5, 6, etc., as we are now, back in Framework World, I was using Autofac. Prior to that, I was using Unity as well from Patterns and Practices. And when .NET Core came along, I was used to Autofac. So I saw this new thing, but I could see you could use Autofac with it. So I just carried on using Autofac. And a bit like you've just sort of said, gradually over a couple of months, I was going, I'm not actually using anything in Autofac that the out-the-box container can't do. So with that, I just dropped it and started just going with the out-the-box container that started with .NET Core.
Did you find that once you did drop it, was there anything missing at all, or was it just the same?
Yeah, there are a few things missing. So in the talk, I list out a few things. The .NET Core one, I keep referring to it as .NET Core, but I ought to call it just the .NET one, really. Now they're in .NET 5 and .NET 6. The .NET one, out of the box, is just doing constructor injection. That's all it's there to do. If you're using ASP.NET Core, then you do get method injection added as well. So if you've got an ASP.NET controller and you've got a parameter that's going into an action method, for example, you can decorate it with the from services attribute, and ASP.NET Core will take care of that method injection. That's not the container doing that. It's doing some funny stuff behind the scenes to talk to the container to get there for you. You've also got property injection, where you've got an object and then you go and set the properties from the container. And then lastly, you've got named or keyed injection, where rather than saying, I want a type of this or a type of this interface, you say, I've got a string or a constant or an enum, and the container has registered a particular service against that name, for example. The .NET one doesn't do those out the box. Now, things like AutoFac do them. And what you can do is in .NET, you can bring the two things together. So you've got the standard iService provider, which is the .NET one, but you can sort of wire it in so that something like AutoFac or Unity, they're doing the actual newing up of stuff and passing it through the container. But then you can access the methods on those third-party ones to go and do all the fancy stuff that the .NET one doesn't do. Now, Mark Seaman has coined a name for this, and he calls the Microsoft one a conforming container, which is kind of a sort of fancy way of saying it's the lowest common denominator of functionality that Microsoft determined that's what they wanted it to do and didn't really take it any further.
Going back to the dependency inversion, I remember many years ago we actually had a conversation about what different types you should be injecting, like abstractions over interfaces.
Yeah, I remember that. Yeah, we talked about how ideally you shouldn't be injecting concrete types, because what happens if you then want to change it to a different type? So this comes back to solid principles about substitutability effectively, because if you lock yourself into, say, widget A and you inject that and then you want to come along and use, say, widget B, well, then you've got to rewrite your class. This comes back to the solid principles about abstractions and using different ways of being able to substitute things. So obviously you've got two ways of doing that. You can either use abstract base classes if that's appropriate, but most people tend to lean towards using interfaces. So that gives you your polymorphism of being able to substitute things. And it comes back to the substitution principles and later on interface segregation principles.
Yeah, I guess that must tie into a lot, and I know this is kind of a controversial subject with people that are quite into testing, but the whole mocking libraries like MOQ and then substitute. I'm actually personally a big fan of mocking libraries and just being able to mock out the implementation detail in the tests.
Yeah.
And the test being able to verify if something was called, or just say, if this is called, then return this mocked data. I just find that so powerful.
Yeah, and certainly things where it's a function or you just want a particular property tested, that's great. Where I tend to lean more towards writing a concrete that just is a little bit more than a mock is if you want to sort of say, for example, if it's been called so many times, you keep a counter inside your own implementation so that you can go, yep, this has been called so many times, or there's an expected behavior that you can't quite just do through, say, a Lambda mocking, or for example.
Yeah, I quite often use the verify where you can say exactly how many times it should have been called. But mocking libraries is probably one we could have an entire episode on.
Oh, gosh.
I do remember, was it last year or something? I did a tweet about mocking libraries. I think it was a poll, actually, just out of interest, what people's favourite ones were. And wow, that was a minefield of replies.
Yeah, I mean, my personal one is N substitute. Is the one I tend to lean towards.
Two big projects I worked on recently have used MOQ just because that's what they've used. And I find that both MOQ and N-substitute, they do the same thing. So, and I'm kind of used to both syntaxes, so I don't mind which one I use. But as far as just more intuitive syntax, I think, and that's where N-substitute shines.
Yeah, and I think when you were talking to Jason Bogg in a previous episode, he said he looked at mock and didn't get it, and then looked at N-substitute and the penny dropped and went, I get it now.
Yeah, I still need to look at his own one. Was it Rhino Mocks or something? No, it wasn't.
Was it Rocks?
Yes, Rocks, you're right. Yeah, so I think he's rewritten that recently. Source generators was the topic of the podcast episode, so he's rewritten that to use source generators, and apparently that's been a ridiculous speed increase, which makes sense because you're no longer doing it at runtime.
Yes, and certainly it's interesting that Microsoft are now looking at the JSON serializer for .NET 6 and rewriting that using source generators. It's been a massive performance increase in it, apparently.
Oh, I can imagine. It's stuff that was happening through reflection. It's no longer happening at runtime using reflection. It's happening at compile time. So the runtime performance is going to be like 0, hopefully.
Yeah. I mean, what's interesting is that people have sort of said, what about regex? Because you've got different ways of running regex. There's interpreting the pattern at runtime, but then you can do a couple of methods where you say, go and compile it at the startup in memory, or go and compile it to an assembly. That to me is screaming out to become a C# source generator.
Yeah, definitely. I think we're going to find more and more use cases for source generators, and people are just going to have like more and more ideas. And I think this is a good thing about everything so much being open source at the moment. It means that these ideas, more people have visibility of people trying different things.
Yeah, I think it's a GitHub repository that's called something like the Source Generator Cookbook.
Ooh.
And there's lots and lots of examples in there of work that people have done or pointers to other GitHub repos.
That is definitely going to be one for the show notes. So I guess one thing that it sounds like people get tripped up on as well with all this dependency injection is scopes and different lifetimes and stuff. And I can tell that the listeners can't see your expression now, but I can tell this is a big one.
Yeah, so most containers, and certainly the .NET one, support 3 basic lifetimes. You've got the singleton lifetime, transient lifetimes, and scoped lifetimes. So with singleton, it's kind of similar to the old Gang of 4 singleton pattern in that Highlander, there could be only one. Now, where it differs from things like the traditional Gang of 4 singleton is that with the traditional one, you have to write a load of boilerplate code to go and create a single instance. You have to be wary of threading. Now, John Skeet many years ago wrote a blog with about 6 or 7 different ways you can go and create a singleton using the traditional patterns, and eventually landed on, when .NET 4 came out, using the lazy type in .NET, because that takes care of making sure that it's not creating it multiple times with different threads. You don't have to write all that boilerplate code when you're doing a singleton in a container, because you can use pretty much any .NET POCO. You can just say, register it as a singleton with a container. First time it's used, it will spin it up, and it's there until the container disappears. At the other end of the spectrum, you've got transients, which are kind of like your fair weather friends. They come and go as you need them. So say you've got something that just needs an instance, and it says, right, I'll fire it up. And then when your particular thing disappears, then the garbage collector will kick in, it'll take that away, and it'll take your transient away for you. Scoped is the one that people get kind of tied up in knots about. So over the past few years, I've seen blog posts and Twitter comments saying, my project, we've banned them because they're an absolute nightmare. You get yourself in a right old twist. Bit extreme, but I get where those people were coming from. So to put it into context, if you've got singleton lasts for the lifetime of the container and transients last for as long as you need them, scoped, to give it its proper title, is related to a unit of work. So whilst you're doing that unit of work, it will start at the unit of work, and when the unit of work disappears, the scoped instance will disappear. To give that more of a real-world example, and the one that most people are familiar with, it's in ASP.NET, where you get an HTTP request comes in, the scope starts when it's hit the server, it does all its stuff, and then it disappears when the response goes out. I say it sits between the two because it's a bit like transient in that it has a much shorter lifetime than a singleton does, but it's like a singleton in that multiple things within that unit of work, the scope, will share that same instance.
So just to make sure I'm understanding, so a singleton is just one for the entire process, effectively.
Yeah.
Scoped is per request.
If you're using ASP.NET, yeah.
But the same interface that gets injected throughout the entire code base for the same request is the same instance, but two different requests.
Two different requests get two different instances.
Cool. And then transient, every single injected thing is its own instance. Have I understood that?
Gets a new instance, yeah. Yep, that's right.
So when would you, for the scoped one, when would you use that outside of a web API or something? Because I've sometimes seen if you've got a console app and you've got the host builder thing and blocks of, I think, is it begin scoped or something? And then you've got a scope there.
Yeah, so off of the service provider, you can do a create scope. And what that does is effectively creates another instance of a service provider, and you can access your transients and singletons in there, but you can get your scoped instances as well. Now, in the context of a console app, I struggle to see where you would necessarily do that, unless perhaps you're doing some kind of hosted service thing, or you're doing a multi-threaded thing where different threads may want different instances, and you're into the sort of thread alignments in there. Other than that, I can't really see that much of a usage for scope. But people listening might have gone, aha, I've got a thing where I've done that.
For any of our listeners, if you have, then please do comment on the website. I'd be quite interested in hearing all the different use cases. But like you, I've not actually seen that. That's why I couldn't remember whether it was begin scope or create scope, as you say.
Yeah, and it gets very convoluted because you create a scope and that gives you a container which you then have the service provider, and then and it sort of starts going down and down the hierarchy to get to what you actually want to get to. Whereas, of course, that is all hidden away from you in the main container in ASP.NET, because what it does is when you get a request in, it builds up a request service feature, and that takes care of the calling the create scope, and that in turn gets the service provider, which is a thing to go and get the service scope factory, creating the scope, and it goes down and down and down. That does it all for you. As far as you're concerned, is you can use scoped instances within the context of a HTTP request response lifetime, and outside of that, you stay away from them. Where it gets a bit tricky, and we might come on to it later, is when you get into the realms of middleware. Shall we talk about middleware now?
Yeah, we can do.
Okay, so with middleware, there's two ways of registering and using middleware. So when .NET Core first came out, it uses what's called convention-based middleware, where what happens is you write a class, and that has a request delegate that gets passed in. Where it gets a bit confusing is that the request delegate that gets passed into the constructor of your class, that's effectively a singleton. It just creates your instance once and it passes the request delegate in. That's the thing that changes you to the next middleware, to the next middleware, to the next middleware. Your HTTP context and any other things that you want to make use of, you make as parameters into the invoke method. Because it's doing it in the invoke and it's doing it all through reflection, that is effectively scoped, and that's on a per request basis. Now, when I first started writing middleware, I made the mistake of having, I think it was a configuration. I'd used the option snapshot, which is scoped, injected it into the constructor of the class, and it wasn't changing. Went, don't understand it. Go away and sort of scratch my head and read the documentation, which us developers never like doing. Went and read the documentation, went, okay, it has to go into the invoke method. Obviously, this was a bear trap for quite a lot of developers. So when .NET Core 2 came out, Microsoft came along with the iMiddleware interface and turned it all on its head. So with that, if you've got any dependencies, those get injected into the constructor, and the HTTP context and the request delegate get passed as parameters into the invoke method. So it turns it all on its head. But what that does mean is you have to register your middleware with the container, whereas convention-based middleware, you'll register inside the configure method, and you'll use the add middleware inside there, or use middleware. Using the iMiddleware interface, you do that as part of your dependency injection registration, and you do that in the configure services method.
It sounds like the new version is a lot more consistent with other ways of doing dependency injection as well. So I remember with Azure Functions, like the new .NET 5 isolated functions, one thing that tripped me up was that I was that used to injecting iLogger into the actual function execution method. And then it wasn't working. But then I realized, oh, actually, dependency injection now works in Azure Functions like everything else, and you inject it into the constructor, which is actually what I would normally naturally do, inject it into the constructor. But because I was migrating an Azure Function project from pre-.NET 5 to .NET 5, I still had iLogger being injected into the actual method, and it just didn't work.
Yeah. So middleware, as I say, there's so many bear traps of that ilk where you can do it one way and then suddenly it changes to another way. The difference is with the iMiddleware based, you're effectively creating a new instance of the whole middleware class each time it's being called. Whereas the convention based, it's just the one instance that gets created by reflection. And it's your parameters, creating the dependencies using the parameters of your invoke method. That is the difference there. So I think if you've got a web server that's getting absolutely hammered with lots and lots of requests, there is a worry about garbage collection and memory if you're using the iMiddleware interface, because it's going to be spinning up lots of them. But on the other hand, it's only there for the lifetime of a request response. So if you've got a quick thing, is it generation 0 in garbage collection? Yeah. Is the short-lived ones? Yeah.
Yeah, that's cool. I guess it depends how many requests you're getting in per second as well. So if you're getting a lot of them in.
Yeah.
But yeah, it's interesting with most developers that have done ASP.NET development and created web APIs are using dependency injection just as standard. When you go a bit deeper, I guess only a small percentage know of these little caveats. In the last episode where we were talking about Git, I think Jesse said that 90% of developers actually use Git. But then from my experience, a lot of developers that use Git actually don't properly understand it and don't use it properly. And it feels like with this, that .NET Core developers now, well, pretty much all of them will be using dependency injection. But it'd be interesting to know how many understand scopes or all of these kind of areas of dependency injection.
Yeah, middleware's a funny one because obviously going from framework world where you had your handlers and modules, I seem to recall HTTP handlers, HTTP modules, going over to this new middleware. Effectively, they're doing the same thing, but it's just a completely different programming model because it's using dependency injection, whereas back in framework world, you were having to do all the hard work yourself. And certainly the first year I was using it, the whole sort of thing about scope, and that's where I made the mistake with the middleware. And that's when I started going into it a bit deeper and going, well, why isn't this working? Read the documentation and went,
But on the plus side, it's giving you a nice niche to do talks in.
Oh, it is, yeah.
Have you thought about doing a Pluralsight course or something like that on it?
Steve Gordon's already cornered the market. So Steve has got a really good course on Pluralsight.
Another Steve. It's like
He was your first guest, wasn't he?
He was my second guest. So
second guest.
Episode 2, we had Derek Comartin, and episode 3, we had Steve. And yeah, he does an awful lot of stuff, doesn't he?
Oh my gosh, it makes my head spin the amount of stuff he spins out.
we just need a few more Steves, don't we? So like we've got all the Scots.
Yeah, get Steve Smith in. Have a triumvirate of Steves.
Yeah, well, who else? There's Steve Sanderson as well, isn't there? So that's four Steves. You're beating the 3 Scots now.
I would definitely be a lesser Steve.
There's no such thing as a lesser Steve. So going back to where I mentioned with the Azure Functions that I always default to using constructor injection. I don't think I've ever really used any other form of injection. That's just been my default. Do you tend to have any other use cases where you find that constructor injection isn't a good option?
So I think with that, it's not so much about your own code. It's if you're using, say, some kind of class that is in a .NET standard library that someone else has written that you want to consume, but it's been targeted back at framework. So they haven't necessarily thought about using constructor injection in there. So for example, back in framework, we had several classes where you'd instantiate it, then you go and set a few properties, and then you call something like an init or initialize. One that comes to mind was back using the old configuration type in framework, where I think there was various bits and bobs where you effectively, from your configuration, you set your properties in your web config or your app config, And then it did some magic behind the scenes and it called an init method to go and do that. Now, if you're using some third-party class or something like that, and they've gone down that road, then constructor injection is not going to help you because it'll go and new up your instance, but then you've got no way of setting those properties and then calling init. So to get around that, what you can do is go back to, say, the gang of 4 factory pattern, where what you do is you write a factory method, or you could potentially use a proxy. But what you're doing behind the scenes is you're filling in the gaps between doing a constructor injection and a property injection. So to take factory, for example, you could consume all the dependencies that you would need to set those properties, for example. Inside that constructor injection of your class, you go and new up this third party one, set all the properties you want, call the init, and then return that via a method called, say, create or build, for example. Named and keyed is a much more nuanced thing. And sometimes it's referred to as a code smell or a bad practice. But there are sometimes you did it. And what led me to dig into this a bit more was I had a particular scenario where I was reading some rows in from a database, and then I wanted to use different mapping type classes to map from different row values into use different calculations. Now, there's various ways you can do that. But what I wanted to do was take a string that had come out of the database and use that to look up which mapper I wanted to do, and then pass in the rest of the values into that mapper to go and get my mapped instance. Yes, you can do that in AutoFac and various things like Unity, I think. But certainly the .NET one can't do that. And this led me down a sort of rabbit hole of working out, well, how can I do that? And I've written a blog about it, about how you can go back and use something that doesn't get a lot of publicity these days, and that's delegates. Because with the .NET container, people think about interfaces and concrete classes, but the delegate is behind the scenes. When you get down to IL level, it creates a class behind the scenes, so it is a reference. But to give it its full information, a delegate is a signature of a function. So in .NET Core, you're probably familiar with things like the func and funct, func t1, func t2, etc., or the action. Those are pre-baked delegates. And back in Framework, we heard things like event handlers as well. These are all delegates. They conform to a particular signature. So then I got to thinking, well, if I used a delegate and said, I want to pass in a string and I want back a particular mapper, if I can register a delegate and get the container to work out what I want based on that string, then that kind of does the same thing as having a named or keyed injection. So off I went, and I've written a blog post about it, and I'm sure we can put it in the show notes. But ultimately, I ended up with this thing where you inject the delegate into your consuming class, and from there you hold that. And then when you want to go and call the mapper, in this, my example, then what you do is you would invoke that, pass in the parameter, say mapper A, and you get back an instance of mapper A. So those are the things where you start to move outside the realms of what the conforming container, the Microsoft one, can actually do. But there are workarounds for it.
That's really nice, actually, because it sounds like you're creating a factory, but without creating a full class and interface and stuff. Where I've tended to do that kind of thing in the past, I've actually created an I whatever factory and then an implementation that then has a method to return something. But if you can get rid of all that and just make it a bit more functional, and instead of registering the interface, you're just registering the delegate itself. Sounds a lot cleaner.
And another use for it, and I'm sure we'll come on to talking about testing in a minute, but one of my real pet hates is having system date time now baked into a class, because you just can't test it. Now, various people have sort of said, well, what you do is you go and write an interface as an abstraction and then have a method that says get time. But the delegate way, you can take a lot of that boilerplate out and just say, I've got a delegate that says get date time, doesn't need any parameters, and it returns you a date time. And then inside your registration in your startup class, for example, you can just have a Lambda expression that says, when I get one of these delegates, just call system date time now and return that. The joy of that is, we talked about abstractions earlier, is because you're using abstraction, it just happens to be a delegate. When you write a test for it, you can create your own Lambda expression that says return a fixed date time that you can then test against in your unit test.
Out of interest, if you're registering a delegate with your IOC container, if a delegate is literally just the method signature, what stops conflicts between two completely different delegates which happen to share the same signature?
So this comes back to the difference between the generic func, for example, as a delegate, because that is very generic, and C# delegates as you had in .NET Core 1. Well, sorry, .NET Framework, when that came along. Because when you go and create one of those delegates, you give it a very specific name. And effectively, that it's almost like a class name.
Ah, gotcha. Yeah.
So if you can have multiple delegates with the same signature, but if you're explicitly saying, I'm going to register it against this delegate name, and I will take in that delegate name, then you created a tight coupling between those two.
I gotcha. So it's a named delegate, and it's not the signature that it's matching against, it's the name. Cool, that makes sense.
Yeah. Because if you then had something that consumed just, you expressed it as an anonymous function, then that's where it just wouldn't work, because you can't just register that function in there. It's the delegate that, if you look at the IL underneath, it goes and creates a class.
Taking this to maybe a further extreme, where just going much more functional, where a lot of functionality is injected as high-order functions rather than having all interfaces everywhere. So I guess that's probably another question. It's where does the balance come between that? You see a lot of .NET projects where pretty much every single class has an interface just to follow this pattern. Do you find that sometimes that's overdone?
I think that some people argue, do you need dependency injection at all? And I think if you've got a really tiny little console app, then do you really need dependency injection? But then you walk it back and go about testability. And to do testability, you need some kind of abstraction. So I've seen various things on Twitter and blog posts about why is it you've got all these hundreds of interfaces and abstract base classes and these classes, why not inject the concrete? But by injecting the concrete, you are doing the tight coupling. So it does feel sometimes like you're writing a lot of boilerplate to do these things. The joy of the delegate way of doing things, and it's effectively a functional way of doing it, is if you only have a single method on, say, a class, then why not just write it as a function?
Yes, yeah.
Because then you don't need all this other boilerplate with it. But if you've got multiple methods and properties and all this thing, I think you are pretty much bound to having a class and an interface. But also doing the interface thing, if we come back to the solid principles, you've got things like interface segregation principle, where if you've got a class that has got certain different things, but you may only want a subset of that functionality, then you can split it out into multiple interfaces. That gets interesting with dependency injection, because if you try and register a class against multiple interfaces, by default, if you're doing, say, add singleton, interface as service, this class, you'll get a different instance of that class where you call via the different interfaces. So with that, what you have to do is actually register the concrete class with the DI container. But then what you do is you then write other registrations, one for each interface, but then you use a Lambda expression that uses the service provider to go and get that one concrete class that it's created. So that way, instead of having, say, if you've got a class with 3 interfaces and having 3 instances, you just get that one instance back because you've used the service provider to resolve back to that original concrete class to go and then, but then you're exposing it through the 3 interfaces.
I understand, I think. I think this is where audio becomes more difficult. But
yeah,
I'm actually worried because I think I do understand. So that's kind of, I guess that's a good sign, isn't it?
Yeah.
So you mentioned about a single class having multiple interfaces. Quite often I've hit scenarios where I've got an interface where I've actually got multiple implementations of it, but depending on what scenario in code, I want to inject in different implementation details. Is there a way around that without using factories and that kind of thing?
So what you can do is, if I take a step back, so say you've got interface A and you've got class A, class B, class C. Then if you go and say, add singleton interface A, class A, add singleton interface A, class B, and so on, so on, so on, then the .NET container works on the basis of a last in wins principle. So if your consuming class says, I want one instance of interface A, then whatever the last one you registered will be the one that gets served up. But what you can do is you can say, I want an IEnumerable of interface A. And what you'll get is you will get an enumerable of all the things that got registered with the provider. Now, what you may then want to do is it depends on how you want to differentiate those things. You might have some property on there where you can differentiate them and then go and create a dictionary, or you may have each one implement some other interface and you can test each one for the interface. What I wouldn't necessarily advocate is testing what the concrete implementation name is, because that may be an ever-shifting sands underneath you. But by doing that IEnumerable, you get all the different implementations, and then it's up to you how you sort it. What you will find, though, is if that IEnumerable, you'll get them in the order that they were registered with the container. So if the order you get them is of some consequence, those concrete classes you may want to implement iComparable, something like that, that gives you some kind of sorting. So you can do a link query and say order by whatever you want to order it by to get them into the right order.
Gotcha. I have tended to do like dedicated factory things to get around that. But yeah, it sounds like there's lots of different ways around, and it's just knowing them all so you know which one is the best one for that particular scenario.
Yeah. And certainly I'm not saying that don't go use a factory, for example, because you could embed all that logic inside a factory. And it kind of comes back to what we were talking about with named or keyed injection, in that you've got something where you say, I want one of these. Abstract factory, please give me what's most appropriate based on some kind of criteria.
Yeah, definitely. With these IOC containers, if you've got a concrete type which implements iDisposable, so it needs to call this dispose method, how is that handled by the IOC containers?
So in most cases, the container will go and dispose an instance for you if it detects that there's an iDisposable interface on that particular class. But there's a couple of times where it won't necessarily do that for you. And one of those times is if you use a signature where you go and instantiate that class within your registration code. And what happens there is because the container hasn't instantiated it itself, it doesn't know it's got to dispose of it. What there is a backdoor way to it that Andrew Locke put on a blog post, and that is the iHost application lifetime. And that is automatically registered. And I think that is part of ASP.NET's registration. But what that does, it has a property on there called application stopping. And that in turn has got a register method. What you can do on that is you can register for the application shutdown event. And inside there, you can ask it to give you the instance that the container has resolved for you. And then you can call the dispose on that. But that is really messy. So what my personal preference would be to do is if you've got a situation where you need to new up something and pass some parameters in from outside the container, is, we've talked about factories before, is effectively create a factory class to do all that heavy work for you and then call the factory method on that from within a Lambda expression within your registration. And that will trigger the iDisposable to get called.
Yeah, that makes sense. Yeah, I think sometimes, whilst you wouldn't want to overuse factories, sometimes I've seen developers that aren't used to the factory pattern at all really tying themselves in knots over trying to use dependency injection in really complicated ways when a simple factory would have just solved a lot of problems. So it's definitely a good thing to have in your toolbox. Before we move on to dev tips, are there any common mistakes that you tend to find developers make with dependency injection?
So not so much a common mistake, but an unfortunate thing that can happen is, say you've got code bases that get merged together. So you've done a git merge and something's gone wrong. So you might see a registration of, say, an interface being done with class A and an interface then with class B within the same startup registration process. Now, I mentioned that earlier that the container out the box works on the last in wins. So if that merge has gone wrong and you really wanted class A registered and class B is below it because the git merge has gone wrong, then that could be a problem. But hopefully a code review would pick that up. But it can also happen when you're depending on NuGet packages, and it comes down to the person who's written the NuGet package behaving themselves and using the right way of doing some registrations, but also which order you use if it's, say, done through an extension method, whether you've called their extension method before or after your registration. The way to get round that is there's alternatives to things like add singleton, add transient, etc. And that's the triad versions of them. So, as we've said, by default, it's last in wins. Using triad, it's a bit like the triad with a dictionary, in that it flips it and says, if I've already got this, I'm not going to register it again. So it becomes from a last in wins to a first in wins, because even if you register 200 things after that first registration, it's that first one that's going to get served up. That is useful if you're writing a NuGet package and an extension method that does the registration for other people, because you don't know what other people may have done and how they're going to consume it. So if you're writing a NuGet package, it's better to use the triad registration methods rather than the straight add methods.
That makes sense. So that was going to be my question before you mentioned more about NuGet packages. Would you recommend everyone do that? But it sounds like if you're a library author, and use triad, otherwise just use the normal add singleton or add transient.
Yeah, and I think it's how well you know that code base as to which way you jump. If it's sort of a code base that's got lots of extension methods calling left, right, and centre to other modules that other teams have written, you may want to use triad to start with. And then if you're not getting the thing that you're expecting, then maybe you need to sort of work out, well, why am I getting this other thing? What have I already registered, either myself or another team's done it through an extension method, before you just go and you use the add method, because you may not necessarily know what dependencies there are back further through the chain that if you're putting yours in may get upset by your implementation.
I see. Is there any way, like just going back to your first example of like merge conflicts, is there any way you can tell the IOC container that if any same interface is registered twice, throw an exception?
I'm not aware of one. I'm just trying to think. I'm not aware of it because it's got this sort of default last in wins, and because people write extension methods and you could have any number of registrations coming in. I think it works on that last in wins basis, because if you get an exception thrown during that registration process, everything's going to just stop.
Yeah, I guess like it's the typical it depends, isn't it? I think in my own code base where I'm registering my own interfaces, thinking of what I would want it to do, I think I would want it to throw an exception if I registered the same thing twice. But then, as you say, you've got other things registering things as well, like NuGet packages and things. So again, it depends. I use that phrase an awful lot. It depends.
It's the IT guru's default phrase. It depends.
Alongside, turn it off and back on again. It depends. Cool. So shall we do dev tips?
Yeah, sure. So my dev tip is a site called SharpLab.io. And what that is useful for is you can put code in and try and debug. But what it does is it gives you IL disassembly. And it's really useful for things like, so in C# you have this concept of things like lowering, where you might write your code in a certain way, but behind the scenes it gets lowered down to slightly different code. And you can see what actually will get generated from your C# code. It's also really useful if you're doing things like Roslyn analyzers or source code generators. It has a thing where you can see the syntax tree, and it graphically shows you with sort of a tree view of the syntax tree of what your code is doing. So you can cut and paste into this. Now, I know there's some tools built into Visual Studio, but if you've got something like Visual Studio Code, or I don't know whether there's a similar tool in Rider, it's a way where you can just cut and paste some code in and sort of say, this is what it's going to lower to. And also it supports lots of different versions of C#. So you can see how it works in different versions of C#, including all the upcoming sort of versions that haven't necessarily been released.
I need to play around with more of these web-based tools like this, because because I've been a link pad user for quite a long time. So if I just need to do a quick bit of proof of concept code, then I do it in LinkPad, and LinkPad, like, it's got the IL that you can basically drill down on things. But I know that more and more recently I've been hearing a lot of these web-based tools like SharpLab, and I think there's a few others which they seem to have got really good lately. So I need to have a play.
Yeah.
So my dev tip is basically it sounds like a simple one, but to actually test your code before passing it on. And I don't mean write automated tests. Well, do write automated tests, but that's not what I'm talking about here. I just mean, and this might be me being rubbish, but I find that quite often, even with changes that seem pretty safe and that works locally, they might fail for some other reason when deployed, maybe configuration or environment differences. And you might be lucky to have like a QA team that does this for you, but relying on your QA team and not testing it yourself anyway just wastes a lot of time going backwards and forwards. And if you are lucky to have a QA team, then I would recommend challenging yourself that they will not find any bugs in your code. Like make it a challenge, make it a game. And I do also highly recommend that teams have a definition of done before tickets get resolved. And testing the code actually does work should definitely be one of those items. So basically, don't just push to Git, then immediately resolve the ticket, assuming that CI/CD will deploy it and everything will be rosy, which is something I see happen quite a lot. Cool. So before we wrap up, is there anything else you'd like to mention?
So if people want to get in touch with me, I tweet quite a lot at Steve Talks Code on Twitter, and that's also the name of my website, stevetalkscode.co.uk, where you'll probably find quite a few blogs about dependency injection, and I'm starting to tinker around a bit more with source code generation, which obviously Jason Bogg spoke about in a previous episode.
Yeah, so I think actually your dev tip with the SharpLab, it rung a bell from somewhere, and it might have been him that mentioned it in maybe another conversation somewhere, where for the same reason you mentioned, with basically seeing the syntax tree.
Yeah, I mean, I've been playing around with sort of source code generators, but I've gone very much down the sort of writing it as complex strings and doing replaces, which gets quite hideous. But if you're having to go and look at sort of listen to triggers of certain things happening, then that's when the syntax tree and the semantic trees start to become much more interesting.
I can imagine. Cool. Well, so that just leaves me to say thank you so much for joining us. It's been absolutely amazing having you on, and I'm sorry it's taken so long.
Thank you for having me, Dan. It's been a pleasure and really enjoyed myself.
Brilliant, thank you. And thank you everyone for listening. And a quick reminder that this podcast is sponsored by Everstack, which is my own company providing software development and consultation services. For more information, visit everstack.com. And if you're enjoying the podcast, please do help me spread the word on social media. I normally use the hashtag unhandledexception, and I can be found on Twitter @Drakan, and my DMs are open. And my blog, danclark.com, has links to all my social stuff too. And we will include links to all the stuff we've mentioned today in the show notes, which can be found on unhandledexceptionpodcast.com.